Good morning, boys and girls, and welcome back to the eastern wing of the Stinkbug Works. We're ready for, I guess this is part 5 of building the MHZ Miss Madison. So Wayne, I hope you're watching this. So let's go through where I am now and what my plans are. The motor has been glued in. So I first glued in just the aluminum bracket, then I pulled the motor out, and I came back here with fiberglass or milled fiberglass and epoxy and got that leg down there. And this thing isn't going to go anywhere now. It's plenty solid. Oh, my hand is touching something. I should have talked about this a whole lot sooner. When you're working around this thing and laying it down on a piece of wood and such, you got these sharp edges here that want to stay sharp. So I just took a little scrap of G10 and taped it on the sponson edge. So when you can see how it's getting the abuse right there. So I can abuse that all day long, pull it off, and I'll have a nice edge underneath there. So as you're slamming this thing around on the bench, think about your poor sponson edges. If you take care of them now, you won't have to work so much on them later. So today we're going to install the rudder linkage. Now, here's where it gets tricky. You want your rudder push rod to be a straight line between here, which is fixed, this position is fixed, and the servo, which right now can go anywhere it wants. But you also have to consider the arc that this arm moves through, and you're going to go through a bellows somewhere in here. So you need to establish where this bellows is. Now lately, I've started to use these bigger diameter bellows. This one is actually 10 millimeters on the outside. And the reason is it allows more side-to-side movement as things swing through an arc. If the bellows is right here in the middle and it's going like this, well, it's not going to move so much. But if you're at one of the ends or close to it, then you're going to see a whole lot of side-to-side movement as it moves in and out. So you need to establish the horizontal line where your push rod's going to go, and you need to establish a vertical line. And to establish a vertical line, I took a little square and said, okay, there's the very outside edge of this push rod. It should almost touch the outside edge of that metal through hull after it's glued in. So, the outer edge should be, no further that way than this right here. And the inner edge, well, now you need to look at how much rudder, and I'm going to have about that much rudder, and that's going to get close to this ball joint hitting here. So that's going to be the most rudder I have, and that's going to put this side, the left side, that would be, let's see, left has 4 letters, would be port. The port side of this through hull for the bellows, I want it as close as I can to this bracket, maybe even touching it. So I've established the horizontal and the vertical. And that's where I'm going to start drilling the hole. Now, this thing is 10 millimeters in diameter, and its location vertically and horizontally is important. And I want to show you a tool I use, but I'll bet a lot of you don't have and don't really want to buy. This is a tapered reamer from StuMac, Who is StewMac? StewMac sells guitar parts and luthier tools. This thing is amazingly cool. 50% of it has no teeth. The other 50% have super razor sharp tapered teeth. So as you're going in a hole, you can move that hole by just working one side of it as you move this in and occasionally doing a full thing. So this, and especially going through thin fiberglass, I can start a hole and get it real close with this tapered reamer to where it's like 9.5 millimeters, and then come in with a 10 millimeter reamer and get a perfectly square hole exactly where I want it. So I cheat when I use this thing. Now, StewMac, because they sell guitar tools, they really value their tools and they price them accordingly. This little piece is closer to $100 than it is to $20. Anyway, so that's my plan. And then once I have established where this through hull goes and where my range of motion allows the servo, then I'm going to take a piece of G10, cut a hole in it for the servo, mount the servo with some screws, and then it's actually going to occur on the other side. I'll glue this plate in wherever it is at the right dimension for this push rod. So, you know, I'll just put the servo where the push rod determines it, and there you go. Then I'll come on the other side, this side, and I'll put a support to stop that squishiness. And I may put my receiver there and run a little bracket for an antenna that kind of sticks up, but it would be underneath the canopy, wherever my, so I could have it sticking up into here and be invisible from the outside. Oh, I see I have my hoses in the wrong place. Anyway, boys and girls, until next time, jet out.